And I'm starting the broadcast. You ready, Aaron?
Yep.
Okay, here he goes.
The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to DBAFundamentals' second virtual chapter meeting for the month of September. Today's presentation is entitled The Roadmap to Better Performance Reading Query Plans with none other than Aaron Stellato. I'll be turning things over to Aaron in a few minutes, but I want to bring a few things to your attention first. First, you can put all of your questions in the QA field on your screen. If you have any technical issues, raise your hand using the icon that looks like a hand at the right. We've got several of us that will try to answer your technical questions. Erin's going to be handling questions as she goes through, so go ahead and submit those. You can also send a chat message if you have any technical questions. The session will be recorded and the web broadcast will be available in about a week on the DBA Fundamentals website on the Archive tab. So if you don't catch the whole presentation or get disconnected, you can check back in a week and navigate to fundamentals.sqlpass.org. We'll probably direct things to Aaron's site also at SQLskills, so you'll have multiple options. Some things happening. PASS Summit, obviously, in Seattle, November the 4th through the 7th. I'm going to be going there for my first time, and I'll be taking a pre-con session with Aaron. Fantastic presentation about everything you didn't want to know. Sorry, totally going blank.
Extended events.
Extended events. I'm so sorry. I'm not doing too well today. Anyway, if you want to sign up, save $150 off of the total cost, you can use VCSUM09 as a code, and that'll save you $150 off the total cost of the entire all the sessions. The pre-con sessions are extra, but they're definitely worth it. There's 25 virtual chapters that cover a wide range of topics that can be of interest to you. So check out PASS's website and go to the virtual chapters, and you should be able to see things that are happening at the time. My name is Steve Cantrell. I'm the chapter co-founder of the DBA Fundamentals virtual chapter. You can send us questions at any time. You can find our contact information at fundamentals.sqlpass.org by selecting the About Us tab. In October, we're going to have Mickey Stewie presenting a session called Changing Your Habits to Improve the Performance of Your T-SQL. I think this is the first time we've had a session on T-SQL, and it's an integral part of everything we do, so I thought it would be a perfect presentation for us. So be sure and sign up for that. It's all the housekeeping I can think of for at the moment, so let's get started. Today we have Aaron Stellato presenting the Roadmap to Better Performance Reading Query Plans. I'm going to let Aaron do the presentation for herself because she usually has a slide related to that. So I'm going to turn it over to Aaron now.
Well, thank you, Steve, and thank you to the Fundamentals chapter for having me. So let's go ahead and get started. Just a little background information about myself. In case you haven't heard me speak before, I work for SQLskills, which is a consulting and we also provide training. So we provide consulting for clients, and we also provide training through our immersion events. My website, my blog is listed here, sqlskills.com/blog/Aaron. And my email is here as well, aaron@sqlskills.com. If you have a question during the session, as Steve said, go ahead and post it. But if I don't get a chance to answer it, you can always send an email to me directly as a follow-up. I am on Twitter @Aaron Stellato, and if you are too, feel free to say hello. I'm a SQL Server MVP, and I volunteer for PASS as well. And just a little bit about the SQL Skills team. It consists of myself, Glenn Berry, Jonathan Cahias, Kimberly Tripp, and Paul Randall. And again, we provide training through our immersion events. We also have online training on Pluralsight. If you haven't checked that out, it's a fantastic resource. It's only $30 a month, and we have, I think it's almost 20 classes out there specific to SQL Server. We do consulting, we provide remote DBA services, and we present at conferences. We'll be at the PASS Summit this fall. All 5 of us are presenting. I have a execution plan session, which this is kind of a beginning for that execution plan session at Summit is a level 300, and this is a 100 to 200 level session today. So if you go through this and you're feeling really good about it, I would love to see you at my session at Summit. And as Steve mentioned, we are also doing a pre-con. Jonathan and I are related to extended events, and it's beginning to end all about extended events. And after the Summit is SQL Intersection, where the team will be presenting also. And if you're not an insider, feel free to join. Paul sends out a newsletter every 2 weeks. Not really trying to spam you, just giving some information about what's going on with us. And we usually include a video demo related to something with SQL Server. So let's get to today's session. And here's the abstract. And I include this just to make sure that we're all on the same page and that you know what to expect from this session so that you're not disappointed. And this session is appropriate whether you're a DBA or a developer. And what we're going to do is just cover the basics of query plans, which is how to find those plans in the system, and then the basics of starting to read them. So we could spend hours. I mean, there's a pre-con, I'm pretty certain, related to query plans and performance tuning at Summit. We could spend a lot of time on this, but this is just the basics if you know about execution plans and you've looked at them a little bit, but you're not sure where to go next. So that's what we're going to cover today. So how to capture and view the plan, essential information, and then we're going to start with a couple patterns depending on how much time we've got. So let's make sure that we're all on the same page with regard to our plans. Every time you run a query against SQL Server, the optimizer creates a plan, an execution plan or a query plan for that query. And this tells you how that query was executed, what the optimizer decided to do. And information that's included there is what tables and or what indexes did it use, did it scan or did it seek, what operators will use, and we'll talk a little bit about operators. Sometimes they're also called iterators, but we're talking about nested loops, merges, hash joins. There's over, I think it's 100 different operators as of 2014. The estimated cost of each operation, and estimated cost is a huge thing to remember here. How many rows it expected to retrieve, and a lot more. And it's important to also note what the plan does not include. It doesn't tell you, when you look at the query plan, how long it took for the query to run. If you want that information, you need to use set statistics time. It doesn't give you any I/O information. It gives you an estimate about I/O cost, but it doesn't actually tell you how many I/Os there were, whether data had to be read from disk. And SQL Server, by the way, always assumes the data has to be read from disk. And if you want I/O information, you need to use set statistics I/O. Doesn't give you any information about locks acquired, doesn't give you any weight statistics, doesn't give you the actual cost. You can never actually get the actual cost. And there's a lot more that it doesn't include. What's important to note here is my bottom line here. You cannot use these plans in isolation to tune your queries. There are multiple tools that you need. Kathy Kallenberger said this at a SQL Saturday recently, so I'm pulling this quote from her, is that query plans alone are not enough. You need multiple pieces of information to really tune queries. But the plan is important, and it's important to understand how to read the plan. That's one piece in query tuning. So how do we get this plan, which is essential when we're tuning? And most of the plans are stored in cache, and I'm not going to worry about exceptions today, but not every single plan is always in cache, but the majority of them are. And so this means that the plan cache can be queried. And the plan that you pull from cache is the estimated plan. And we can get this estimated plan multiple ways. We can query the cache directly using sysdm exec query plan or sysdm exec cache plans. We can use set show plan XML to get an estimated plan, and we can get a graphical show plan of the estimated plan. The actual plan is something you can only get when you execute the query, and we can do this with set statistics XML or with a graphical show plan, or we can use trace or extended events, which is not something that I recommend. There are cases where you might need to do that, but there is a lot of overhead involved in pulling the actual plan that way. So I want you to be aware of that. Your first option should always be trying to run it through Management Studio and pulling the plan that way. But understand that when you run the query through Management Studio, your connection options might be, your connection settings might be or probably are different than what the application uses. So there are times when pulling that plan through trace or extended events may be what you need to do, but it's very expensive, and I don't have time today to get into why there's so much overhead and what you have to do, but I want you to be aware of that. So the first thing we're going to do is go right to a demo, because if you've attended any of my sessions before, you know that I'm very big on demos because I like to see. I think it's really a better way to learn than just kind of talking about what's going on. So again, Steve mentioned this, I think, already, and I blasted out a message, which was the scripts and the slide deck will be available for download, and again, the session is being recorded for viewing later on. So we're going to use a copy of the AdventureWorks 2014 sample database, and this is actually the most recent sample database that Microsoft has released. It's not an upgraded version of a previous AdventureWorks database, and we're on SQL Server 2014 CU2, which is the current and latest release. So the first thing that we want to do is we're going to look at the estimated plan, okay? And what we can do is we can highlight our query, and we can go up to Query, Display Estimated Execution Plan. So if we go ahead and run this, what happens, you'll notice, is that we get our plan, and for our messages we get one row return, but notice that the query is not actually executed. When we ask SQL Server for the estimated plan right here, it doesn't actually run the query. It does the processing, the optimizer does the processing to say, okay, what would I do for this query? And it generates that plan and it shows it to us, but that's all that it does. It doesn't actually run the query. Oh, and Sanford has told me that CU3 came out in August. I'm a little bit behind. Sorry about that. I don't know. Pretty recent version of 2014. Anyway. Okay, so here's our estimated information. And what I want to show you here is that in addition to not returning any results, I just get this estimated plan. And we're going to talk a little bit more about these operators. But what I want to mention here is that for these operators, I get estimates. And what does that mean? It means that I get estimates about the I/O, about the cost, and one of the things that's really important that I want to mention here is I get this estimated number of executions and rows. And we'll come back and talk about that in a little bit. But again, my audio is fluctuating a lot. Sorry, Alex, I'll try and stay a little bit closer here to see if that helps us. Let me know. Okay, so here we get these estimates when we're looking at our operators. Now let's see the difference when we display the actual plan. So we're going to highlight this query, and we're going to select Query, Include Actual Include Actual Plan, and we'll go ahead and select Execute here. And now notice that we get our results. So the query was actually executed, and we get our plan. And if I look at this plan, and it's the same plan that we had for the estimate, but if I look, and that doesn't always happen, it did here, but it doesn't always happen. And now if I look at this operator, and I zoom in like I did before, notice that I get, in addition to my estimated number of rows and my estimated row size, notice that I get my actual information here. And one of the things that you start to look for when you're looking at plans and when you get an actual plan is you want to look at your estimates and you want to look at your actuals. And there's a question that says, does that mean that the actual plan won't be stored? So this is something that's really important to understand. The plan that gets stored in cache is the one that gets used over and over. And when that plan gets generated, it's generated using estimates about how many rows are going to be returned. And that plan gets stored and it gets used over and over. But when the plan actually, when you actually run the query, it uses that plan that's in cache. So that's the plan that gets used. When we talk about actuals, when we talk about the actual plan, it's no different than the plan that's in cache, but when you run that and you get the actual plan, you get this additional information right here, my actual number of rows, my actual number of batches, my actual execution mode. That that is just what the number of rows that were actually returned versus the estimates. So the plan that's in cache is the plan that gets used, but when I retrieve that, and I retrieve the estimated plan, it only gives me estimates. When I get the actual, it tells me how many rows it actually returned. Now, one of the things to note about this plan, let's say that I run this in my environment and I have my actual plan. I can take this information and I can save it. I can save my execution plan as a .SQL plan. So I can save this out to my desktop, and then I can share that plan with other people. So this is really useful. I do this with clients all the time. I will say, they'll say they're having a problem with a query, and I will say, well, grab the plan and send the plan to me. So we can do this with the .SQL plan. You can also view the execution plan. You can look at the XML. And I don't love XML at all, but one of the things I love about XML, I don't love it, but I do. I have a love-hate relationship with it. Maybe that's a better way to say it. I can copy this XML. So if I'm looking in a client environment, and let's say I'm remoted in and I can't do copy-paste, I can copy this, and sometimes, in addition to using Management Studio, there's a third-party tool that's free, which many of you hopefully know about, but just in case you don't, which is called SQL Sentry Plan Explorer. This is a free tool, and that's okay. I'm not so worried about that. And what you can do with this tool, which is awesome, is I can take the plan XML and I can paste it right in here. Let's see if I can Control V. There we go. And now it gives me the plan right here. So I love the XML because I can copy and paste that between environments when I can't save a SQL plan and send it to myself. But I can also, if I open from here, I can view the plan this way too from the .SQL plan file. So again, SQL Sentry Plan Explorer, free tool that you can download. I don't even think you have to provide your name and email address. Okay, so we've got two ways so far to get plans, an estimated and an actual, through my query menu. I can also do this with T-SQL. So I can look at the estimated plan, doing set show plan XML on, and then I'm going to run my query, and then I'm going to turn this off right away. So let's go ahead and select execute. Again, query does not actually run. It creates the estimated plan based on the query and the information that I have. So here's my estimate. I can use T-SQL to get an actual right here. Set statistics XML on, run my query, and then I'm going to turn that off when I'm done. Notice here I get my results just like I did when I used the menu to get the actual plan, and then I have the actual plan, meaning when I say actual plan, I mean this is the plan that was used, and it includes the actual number of rows as well as the estimates. So I have a question that says, can there be more than one estimated plan for a query? When I am running the query, either using show plan XML or using query display estimated plan, in this case, it is running the query, and the optimizer is deciding how it's going to get the information in. It returns that plan to me, but it doesn't actually cache that plan. So it's an estimate. It's what it thinks it's going to do. When I actually run the query and it creates the plan and it puts the plan into cache, that's the plan for that query. And as long as the query is exactly the same and it's rerun, it's going to use that plan that's in cache. So let's talk now a little bit about getting that plan from cache. And we're going to run an awful command, which is dbcc free proc cache, which means I'm going to free the entire procedure cache. And I have a sad face because this is not a good thing, because whenever you run the query and it generates the plan, that requires resources from SQL Server, right? SQL Server needs to use some CPU, it needs to use some memory, because it needs to create a plan. When I free the procedure cache, I've basically said, see ya plans, you're out of here. And now every time I'm running a query, if the plan's not in cache, which it's not because I just chucked them all out, it has to recreate the plan. So this isn't something that we run regularly against our production environment. Now there are times when we might run it, and note that there is the ability to run DBCC free proc cache for one specific plan. But today I want to talk about finding the plans, not chucking them out. So I'm going to run DBCC free proc cache, and then I'm going to run one particular query against the sales order header table. So let's go ahead and run that query. I get 1,800 rows back. Now what I'm going to do is I'm going to look at the DMVs that I mentioned earlier. First I have DM exec cached plans. So I'm going to run this query. And okay, I get information, but this is meaningless to me, right? I don't see any columns in here that tell me anything about what actual query was run. Now let's check my other DMV, DM exec query plan. And this is going to fail because I need to pass in the actual plan handle. And if you notice, back here, I do have a plan handle, but I don't know what query that goes with. So in order to use these DMVs, either one of them, you need to join to other DMVs. So we're going to take DM exec cached plans, and we're also going to query DM exec SQL text and DM exec query plan. And using this, we're going to query for particular text, right, like my table name, and we'll see what queries we get back. So this way, when I join these three DMVs together, I can see what the query text was, which helps me find my query, and I can also get plan information. Again, you're going to get a copy of these scripts with the download, and this session's being recorded and will be shown again, so you're going to get this query. Okay, I have two queries. This one is the one I just ran, so I don't care about that one. This right here, right, is the query that I ran right there. This is the query that I executed after I freed procedure cache. Awesome. I have the query, I have the plan, and because I joined over to DM exec query plan, I have the actual plan right here, and I can just click on it, and then I get the graphical view. Awesome. So this is one way that you can find a plan that exists in cache. So you don't necessarily have to take the query and run it in SSMS. You can see what plan is actually in cache and being used. All right, there's another way to get this plan. I can query DM exec query plan directly, but I need, remember, I need the handle. So I could take the plan handle from right here, right click and copy, and we're going to get rid of this, and we'll paste it in here. And if we run this query, ooh, not valid. Really? Let's try this again. Maybe I did something wrong. Completely possible. There we go. Okay, so here's the plan. Query it. I get the exact same thing that I had before. And I can also use DM exec text query plan for plans that are really, really large. One of the things to note about this option, let's replace the plan handle right here, is that notice that when I run this option, this is not clickable. We're going to run both of these together. Here I have a link, and if I click that, it shows up the graphical plan. That does not happen here. What I need to do is copy this, and I could hop into Plan Explorer, Plan Explorer, and I can paste that in here. And I can see the plan that way. I also have the ability right here to save this XML, and then I can save this as, let's pop over to my desktop. We're going to say all files. We're going to save this as the .SQL plan. And then let's find this SQL query 1, right? And we'll drag it in here, and it saves that way. So I can take the XML, I can drop it into Plan Explorer, or I can take the XML, file save as a .SQL plan file, and then view the graphical representation. Now one of the things to note, I'm going to do a new query window and I'm going to paste this in here. One of the things about the XML, even though it looks like craziness right here, is I can search on this. So if I were looking for something specific, like, can't think of anything I want to, let's say memory grant, anything related to memory, I can search on that and I can find that in here, which can be really, really valuable because it's not always easy to find everything in the graphical plan. So there's a question that says, does the cache contain a plan for each and every submitted query? In other words, if two queries are different just for literals and or space, does the system create two entries in the plan cache? This is a great question. So let me run this query again. And notice that I've got two variations of this, which I don't care about right now, but I have this select right here. Now watch what happens if I change, let's put some spaces in here. I'm going to run that query. I'm going to come down here and look at this. Now I have two of these. When it's looking for a match to see if I've run that query before and if the plan is there, it's looking for exact case, spaces, and if I pass in actual literal values, right? Let's put 20 in here. What do I get now? 1, 2, 3. So that's an important thing to know when you're developing your code. And we can go in and we can talk about parameterization, but again, not enough time for this today. If you want to learn more about parameterization and about the plan cache in general, Kimberly has some fantastic courses out on Pluralsight. So hopefully that answered your question, Alberto. Okay, that was it for this demo. So how to find the plan from cache, right? We can use estimated plan, and we can do that through the UI or also with one of our set options, and we can get an actual plan. And we can pull the plan from cache. So let's go back to our slides. Let's minimize this. So I have a couple, I mentioned this already because I had a nice question about this, but I'm going to go through this again because this is a huge thing, I think, to understand when we talk about estimated versus actuals. So the plan that is in cache is the one that has been used, and if you rerun the exact same query, that's the one that's going to get used again. When you retrieve the plan from cache, you only see the estimates. You only see the estimated number of rows, the estimated number of executions. When you get the quote-unquote actual plan, this is so important that I'm reading it verbatim because I wrote it and I just need to say it because it's really important to understand. When you capture the actual plan, it's the same plan that's in cache. It just also includes the actual numbers, the actual number of rows, the actual number of executions. That's it. That's the difference between the plan that's in cache and the actual plan. The actual plan is what's in cache. It just also includes those actual numbers. And the reason that the actual plan is useful is I want to see if there's a difference between my estimates and my actuals. And if there is, then I want to figure out why they exist. And this goes back to stats, which many of you hopefully attended the stats session I did a few months ago. We're not going to get into stats today, but if you see a difference in there, and by difference I don't mean 1 row or 5 rows or sometimes even 100 rows. I mean like orders of magnitude difference, like estimated 1 row, actual 2 million. Okay, that's a red flag. And at the bottom, I have this quote, which is from Kimberly, which is from a session she did at Summit last year, right? The actual plan is absolutely identical to the estimated plan with the addition of actual values. It's the estimated plan with what really happens. So there's a question. I'm going to read it out loud and think about it here. Can the DMExec query, plan query be changed to output the estimated number of rows? So that we could run a query to see all plans in cache and quickly see which ones are not performing as expected. Okay, Dan, when it has the estimated number of rows in the plan, that's what it thinks is going to happen, right? That's what the estimate is based upon the statistics. But I can't get the actuals unless I run the query. So Dan, no, I can't run a query against any of the DMVs to say, okay, tell me what my estimates are and tell me what my actuals are, because the actual numbers aren't in cache. Only the estimate of what it thinks is going to return. Another question from Alberto. So if the first time a query was run, the system decided an index scan. Each time the same query is run, that operation will be done even if a seek would be a better choice. Alberto, yes. So let me say this again. If I submit a query and the optimizer says, hey, for this query, based upon what you've submitted, I'm going to run a scan, that's what it does. It puts that plan into cache. Now when I run that query again, it's going to use that same plan, if it's there, over and over and over again. Even if my data changes, and for some reason my stats don't update, and a seek might be better, right? If that plan is in cache, it's going to use it unless it ages out because it hasn't been run in a while, or unless I remove it from cache. Or if I update statistics, that will invalidate any plans that use that statistic. And by invalidate, I mean, let's say that I ran the query and it needed to do the scan. And I'm running that query over and over and it's doing the scan, but my data in my table is changing, right? And the distribution of data is changing. And so at some point SQL Server says, you know what, we need to update statistics, right? The auto update kicks in. Or maybe I decide that maybe my nightly job runs that update statistics. In that case, as long as you have auto update statistics on enabled in 2008 and higher, 2005 and higher actually, then the optimizer will say, okay, I've updated statistics, so any plan which uses these statistics is no longer valid. And when you go and run that query again that uses that plan, it will say, oh, this is no longer valid, these stats are out of date, I'm going to create a new plan. All right, that got a little off topic. Let's come back to our plans. Alberto, I'm going to come back to that. Essential information in a plan. I've got what tables and indexes were accessed, and we're going to go through this in a little bit more detail. What type of an access, seek or scan, the operators, the estimates, cost and rows, the arrow width, this is important, how much data is being retrieved, and missing indexes. This is some of the essential information. You see my note at the bottom. There is a lot more information in the plan that we can discuss. We're running out of time already. So these are just, again, some of the basics that I want to talk about. So let's flip back to look at a demo. Let's close this one. I don't need to save. And let's look at finding the information in our plan. Make sure we're in the right database. And we are going to create a copy of this table. So we're going to create a copy of sales order header, and it's just going to be everything that was in sales order header into copy. And then I'm going to run a query against copy sales order header. And what we're going to start, now it would be nice if I included the actual plan, Aaron. There we go. So this, I included the actual plan when I ran this. I get my results, and if I look at the plan, I want to talk a little bit here about the information that we can look at. I can see this operator. So this operator here is a table scan. This is a scan against a heap, right? When I created the copy of sales order header, it just created it as a heap. It doesn't have any clustered indexes on it. So I pull this information. It has to scan the entire table. Now, is that a bad thing? Sometimes. What if my table is really large? In this case, it's 31,000 rows. I might be able to do a little bit better here. So one of the things I look for is what actual operator or iterator is being used. I want to look at my estimates against my actuals. Those are accurate. I want to look at the width of those lines, right? How much data is being returned. That's kind of a thick line. Maybe I would want to put an index on here. Hold that thought. I can query my original table. This one has a clustered index on it. It doesn't have a non-clustered index that supports this, and I'm asking for all the information from the table. I'm not even including a where clause. So this time, as you can see, it's doing a clustered index scan. Is this a good thing? Maybe, maybe not. How big is my clustered index? How big is my table? If it's 100 rows scanning the clustered index, maybe not such a bad thing. But if it's 1,000,000 rows, I could maybe probably do better. Now let's run sales order ID and customer ID against our sales order header table. So I'm going to pull this information out, and now notice I get an index scan, and this is against a non-clustered index. So we can see that right here where it says index scan non-clustered, and we can see which non-clustered index it's scanned. Now scanning means it's reading some or maybe all of the information from the non-clustered index. So for an index scan, again, how big is that non-clustered index? How much data is it retrieving? I don't have a where clause on here, so it's reading through the entire non-clustered index. Now let's see what happens if I run this query, give me sales order ID, customer ID, and order date from this table, but I'm going to include a where clause, right, with a particular order date. Let's query this, and let's see what I get for an operator. I get a clustered index scan, again, even though I have a where clause on there, because I don't have an index to support this. And you'll notice that I have a missing index warning. If you see this, that's important to take note of. And you can right-click and you can say missing index details. Now, here's what I want to say about missing index details. This is important information, but this recommendation, right, that it's making, SQL Server saying, dude, you're missing an index. If you created this index, it would really help this query. And it would. It would help this query. It would help this one query. So do I want to add it? Maybe, maybe not. If I added every single missing index, how many indexes would I add to my tables? That's probably not a good thing to add every single one, because remember there's an overhead with indexes. Every time I insert, update, or delete the base table, whether it's a clustered index or a heap, the non-clustered indexes have to be managed as well. And if I have a lot of them, I'm adding a lot of overhead. So there's an art and a science here in terms of what you're going to add for indexes. Now let's look at an index seek. So we're going to query sales order header for sales order ID and customer ID, just like we did before. But now I'm going to add my where clause. Where sales order ID greater than 70,000? Let's execute this. Look at my plan. Now I get a seek. And you may have heard that seeks are great. I don't want scans, I want seeks. And the truth is that it depends. Sometimes the scan might be better than the seek. Sometimes the seek is better than the scan. So the important thing to notice is which operator it is, and then I want to look at how much data is being returned. So here I've got a seek, and when it says I've done this seek, I can look at my estimated number of rows, 5,100, and my actual 5,100. That's the same. That's good. Now, you might think, a seek, that's interesting. Let's see what happens if we force it to scan, right? Because we're thinking a seek is good, right? A seek, we want to seek the index whenever we can. Well, let's see. Let's look at my indexes. And notice that I'm not using the standard SP help index. I'm using a little variation which Kimberly wrote. Actually, it's a big variation. And this is from her blog. So if you Google Kimberly Tripp help index, you'll find this, which you can download and use on your systems. And I really love her variation because it's got a lot more information than the standard SP help index. It gives you the index ID, whether or not it's enabled or not. That's redundant, sorry. What the name of the index is, the description. So for example, in this one, we are using, let's see, what was the index we were using again? Let's look at this. PK, we were using, it was doing a clustered index seek. So because our where clause is sales order ID greater than 70,000, the clustered index is on sales order ID. So that's what it's going to seek. And it tells us what columns exist in the tree and also down at the leaf level. Now, is there a non-clustered index that I could use here? Let's see. What happens if I force it to scan this one, sales order header with customer ID? All right, so here I have a non-clustered index, that has customer ID, leads on customer ID, right? That's my key. And remember that my clustered index also, my non-clustered index also includes my clustering key. So this actually includes customer ID and sales order ID, which I have right here. So what happens if I say, no, I want you to scan this one? Because it can't seek it because I want sales order ID greater than 70,000. That's not my leading column. But that's there in the tree, so it could read through the entire non-clustered index and find the 2 columns that I want. So we can see that with an index scan, I can get the same information. Now, what's better? Is the seek better or is the scan better? Well, let's look at it. Now, I can't tell that by looking at the queries themselves. I need more information. I need more information that doesn't come in my plan. So we're going to use setStatistics.io. We're going to turn it on and then turn it off. And I'm going to run both queries. My regular one where I just let the optimizer decide, and then this one where I tell the optimizer what index I want to use. And I don't know that I really typically want to do this. Typically the optimizer makes a pretty good decision. The people that write the optimizer are pretty darn smart. Let's look at my messages. For my first query, its logical reads 114. For my second query where I scan, scans are bad, you might have heard. No, look at that, it's only 57 reads. Now 114 against 57, not so big. But sometimes this is a significant difference. So in this case, the optimizer maybe didn't make a great choice. It thought the seek would be better than the scan. But for some values, it might be, right? I just kind of picked a value to make it look like it wasn't a better option. Now, I want to talk about seeks because some of you may think that a seek just returns one row, and it doesn't. And a seek doesn't mean that it does this singleton lookup, that it dives into the index and just pulls out one row. And so I want to show you this. What I'm going to do is I'm going to rebuild my non-clustered index and my clustered index very quickly because I want to get rid of the historical information about the index usage. So we have this DMDB index operational stats DMV, which gives us index usage information. And just a reminder, let's look at this again real quick. Let's look at our indexes. The PK, sales order header, sales order ID, leads on sales order ID, and my non-clustered index down here leads on customer ID. So I have 2 indexes, my clustered, which leads on sales order ID, and my non-clustered, which leads on customer ID. So when I query based on the customer ID, what do you think is going to happen here? I'm querying for one customer ID. Let's see. I get 1 row back. So I did the query for one customer ID and I get 1 row. Do you think, and it is, by the way, sorry, let's look at this. It shows me a seek. It says we've done an index seek. Okay. So it returned 1 row. So does that mean that it just dove in and returned the 1 row? It did. But if I look at this information from index operational stats, which gives me singleton lookup and range scan count, notice that it did this thing called a range scan. It actually didn't dive in and just go, this is the row I need, thank you very much. It actually did a little bit of a range scan, meaning it dove down into the index, in the non-clustered index, and then it said, okay, customer ID 19242, do I have any more? It was scanning to see how many it had. Now, let's run this query, sales order ID, again, but I'm pulling it based on the particular sales order ID. So this should use my clustered index. Let's go ahead and run that. What do we get for a plan? I also get an index seek, a clustered index seek, but it's still an index seek. So understand that I can have an index scan and an index seek against both clustered and non-clustered indexes. So now what happens if I look at my operational stats? That did a singleton lookup. Now why? What's the difference between querying by a sales order ID and getting 1 row back and querying against the customer ID and getting 1 row back? I want to look at my index again so that I can show you why that happens. Patience, patience. Here we go. So here is my primary key. Right here is my clustered index. This is the non-clustered index. Notice that this says clustered index unique primary key. Notice that customer ID is just non-clustered. So because this is clustered unique, meaning I can only have one sales order ID, when I queried by sales order ID, when I queried by the sales order ID, the optimizer knows that that value is unique, and therefore it knows that there's only going to be one row returned, and so it can do a singleton lookup. When I queried by customer ID, it is not unique. There's no unique constraint on this index. So when I queried by customer ID, it didn't know that was unique, so it couldn't do a singleton. It had to do a scan. My point here in all of this is that when you see index seek, you shouldn't just think, oh, it retrieved one row. It could still scan a little bit of that index even though it says it's a seek. Okay, let's talk about missing indexes here real quick. We're going to use AdventureWorks. And you know what, I showed you this before, and I'm running a little bit short on time, and so I'm going to skip this demo, but it's going to be in the downloads. What this demo is basically showing you, hey, I have a missing index, and then what happens when you add it. Okay, I've got two questions. I've got a question I'm going to answer that just came from Paul. It says, is there a DMV that we could query to find all queries that have been executed where the actual and estimated stats are different? No, there's not. Because again, the query that exists in cache contains the estimates. The only way to get the actuals is to run the query. So I don't have the ability to look for those queries in cache, or excuse me, look for those plans in cache where the actuals and the estimates are different, because my estimated number of rows exists for the plan in cache. My actuals are not there. All right, let's flip back to my slides. So where do you start? Right? I've given you some information about how to find the plan. I've talked about a few of the things to pay attention to in the plan and what some of the operators mean. But where do you start? And there is no perfect answer. Nothing that I'm saying here is telling you this is where you must start every single time. You've got to start practicing. And this takes time. That's the most important thing on this slide, by the way. This takes time. It takes time for you to understand how to read these plans and to understand how to tune with them and with your other tools. And to me, it's a science and it's an art, just like with indexing. And Paul did an interesting survey, which is, where do you start? So he asked people, what do you look for when you're looking at a plan? Where do you start with your problems? And he got a host of different answers. Some people look at the actuals versus the estimates. Some people look to see if there's sorts. Some people look to see the join types. Others, if I have scans, which was the most popular. But remember, scans aren't always bad. Implicit conversions, row ID lookups, most expensive operators, parallelism. And you know what's not in here? That thickness of the lines that I talked about. Right? And so when I look at a plan, I look kind of for all these things. I'm looking to see, well, what do I have in terms of thickness of lines? Do I have a lot of data moving through the plans? Do I have some scans? Because scans sometimes are good, but scans are sometimes bad, so I want to look at those. Are my estimates and my actuals different? Again, it takes time. There's no right or wrong answer. It just takes practice. So we're going to hop into my last set of demos, which is particular patterns. So this gets into what I'm going to start to cover at Summit. So one of the things that I want to talk about as a pattern is nested loops. And this will probably be our last demo for today. So we're going to go back to our AdventureWorks database. And we're going to make sure to include the actual execution plan. So this is a query that I'm going to run. I'm going to look at the product ID and the count from sales order detail, and I'm going to group by product ID. So let's go ahead and run this, and I'm going to look at this. And actually, that's not the query that I want to run. I want to run this one. Okay, sorry. I think I was messing around here earlier. So I'm going to pull order date, and I'm going to pull subtotal from my sales order header where my customer ID is 29712. So let's look at my plan. Now before, we've just been looking really at seeks and scans. Now what I want you to notice is that I have an index seek here, and I have a key lookup. So let's talk about what we're seeing in the plan and what we care about here. The first thing is I've got an index seek, and let's take a look to see which index this is on. This is on my sales order header customer ID. So this is the index that leads on that customer ID. And notice that my estimated number of rows is 7.8. My actual is 8. That's pretty close. That's good. And I want to point out, sorry, we're going to zoom back in here, a couple other pieces of information in this pop-up. The first is my seek predicate, right? This is what's in my where clause. What am I looking for? And here I'm looking for sales order ID equals my input. And then I'm looking at, well, what's my output? My output here is my order date and my subtotal. Hang on one second. Index seek non-clustered customer ID. I had the wrong one highlighted. I'm so sorry. Let me go back to this. For my index seek, here's my seek predicate, right? Customer ID equals 29712. What's my output? What information does this return? Well, it returns the sales order ID. Because remember, in my query here, I said give me order date and subtotal for a particular customer ID. Well, in this non-clustered index, it just had customer ID and sales order ID. It doesn't have order date or subtotal, which is what I want. So what SQL Server is doing is, since it returns so few rows, it can do this index seek against my non-clustered index, and it pulls back the 8 rows for that customer ID. And then it says, okay, for this customer ID, I also need order date and subtotal. I don't have those in my non-clustered index, so I need to do a key lookup. I need to go over to my clustered index to pull my order date and my subtotal. So if we look at this in a little bit more detail, we're doing a lookup against my clustered index, PK sales order header sales order ID, and my output here is order date and subtotal, right? Here's order date, here's subtotal. And it's doing that using the sales order ID that it got from my index seek against the non-clustered index. So this is a key lookup. I've got information from one index, but I don't have quite everything I need, so I'm going against a clustered index in this case. And when we talk about a nested loop, we talk about outers and inners. And in this case, my table actually is the same table, right? I'm going against the sales order header, but I'm going against 2 different indexes. And my outer loop is my non-clustered index, and my inner loop in here is my clustered index. So what happens is it says, okay, I've got a customer ID. I need you to go, and here's the sales order ID for that customer ID. Now I need you to go get the order date and the subtotal. So it returns that information, and it loops through, right, here's my loop. It loops through to find every customer ID and then the order date and subtotal for the sales order ID that matches the customer ID. Now, let's take a look at what happens when I run these 2 queries. And I get my plans. And notice that this query returns 440 rows. This one returns 3 rows. They have, you'll see, the same plan. I've got an index seek here against my non-clustered index, and I've got an index seek here. And then I have my clustered index seek, my lookup, over here. Notice that there's a difference in my actuals and my estimates. Here I've got 8, and here I've got 1. And I point this out because looking at the actuals and the estimates here, and I'm clicking a lot, I know that. Here I can see actuals and estimates, and here I can see actuals and estimates. Sorry, when I look at this pop-up, and I have to click on each operator to see those. One of the things that you can do in Plan Explorer, and I have an add-in for this, so I can say View with SQL Sentry Plan Explorer, and this is going to open up. Now I can see the estimates I really need to fix that error. I can see the estimates and the actuals when I click on the operators here. I get the same information over in Plan Explorer, the estimates and actuals. But notice what Plan Explorer has up here, estimates and actuals. And one of the reasons that I love Plan Explorer is that for this query, when it sees a significant difference, it highlights it for you. So some of you have asked, well, I want to find plans that have a big difference. Well, I can't get you that from the plan cache, but an easy way to see it when you run the query is to open it in Plan Explorer and look for differences in my estimates and my actuals. All right, what else do we have? What happens to my estimates and stored procedures? This is probably the last thing I'm going to do. So we're going to go ahead and create a stored procedure, which is going to query sales order detail by a particular product ID that I pass in. And what I'm going to do is I'm going to execute this with a value of 902 and then a value with 921. So let's execute both of these. And now let's look at my plans. Ooh. Now when you look at these plans, what's the first thing that you notice? You can just say it in your head, although, you know, if I were looking at you in an actual session, I'd be expecting you to answer. You don't have to raise your hand today. Okay. Notice, first of all, that there's a difference in the thickness of lines, right? We have the same plan because this is a stored procedure. And so it created the plan, and it's going to execute that plan over and over again, regardless of which value I pass in, because I'm not recompiling it. Someone asked me about recompile. I'm not recompiling it. So that plan exists in cache, and it's going to run. But look at this. Here's my index seek. Here is my estimated number of rows, 17, actual 20. Not too far off. Great. What happens down here? Ooh. Estimated 17, because that's the plan that's in cache. Actual 3,000. Ooh, that's a big difference, right? So let's look at this also. If I click on my select, this is something I haven't talked about, but I mentioned once. The estimated cost of this plan is 0.05. The estimated cost of this plan, same number, because it's just an estimate. And it doesn't mean anything about the actual in terms of the cost. So when you're looking at the cost of a query, right? If you look at this, look at this. Query cost, query 1, 50% of the batch. Query 2, 50% of the batch. It says that basically they're both the same cost, but I tell you, this one's more expensive. Let's run it with set statistics IO on. Let's do this, and then let's run this again. Again, 50%, 50%. But if I look at my IO, 62 reads versus 9,000 reads. So cost in a plan is just an estimate. That's it. Now, this plan was generated based on the value of 902 being passed in. What happens if I free procedure cache, again, not to do in your production environment, and I switch it? What happens if I run it with 921 first? I get a different plan because 921 returns a lot of rows, right? 921 returns 3,000 rows. And so in this case, the optimizer says, well, a clustered index scan is more efficient for me. And now if I look at the reads, well, they're the same. And this 1,200 is a lot less than the 9,000 that I did before. But notice that for the query, which previously took, what, 60-some reads? Now it takes 1,000. And if we put on our statistics, again, we see this, right? And if I free procedure cache and run it the other way, so I run the more unique value first, right? 62 versus 9,200. So again, stored procedure is run, the plan gets created, and then that plan gets reused for every value that gets passed in, even if maybe a different plan might be ideal. So let me go back to my slides. We got 1 minute left. I have some resources here which are excellent. There's an article, Statistics Used by the Optimizer. Even though it says 2008, it's still really relevant. There's an internals book, which is there's a 2008 and a 2012 version, Chapter 8, in at least the 2008 one, talks about plans. And then there are a few blogs that I mention here. Craig Friedman has some great info. It's not updated recently, but still good. The same with Connor's blog. Paul White and Benjamin are probably posting the most recently about query plans and optimization. Paul White, fabulous information on his blog. I highly recommend it. So let me take a look at questions. Steve, do I have a couple minutes for questions? Can I take a...
Yes, go ahead. You're on a roll.
Okay, I am on a roll. So if you guys can hang with me for like 5 more minutes, let me see if I can get through a couple of these questions that I haven't. Okay, so Gail had asked a while ago, and Gail, I hope you're still here. How long on average does it take to rebuild the cache for all of your plans if you update stats in your maintenance plans nightly? That's a good question, Gail. Remember that when I update statistics, it invalidates the plan. It doesn't mean that at that moment it pushes the plan out of cache and then rebuilds it. It waits until that query runs again, and then it rebuilds the plan. Then it recreates the plan based on the current statistics. So invalidating the plan doesn't mean that it pushes it out and recreates the plan immediately. It means that the next time you run that query, it's going to remove that plan and it's going to generate a new one based on stats. So the answer is I don't know, because it depends on how quickly you start running those queries again. Presumably you're not all of a sudden everyone's connecting at 8 a.m. and running those queries. I would bet that's spaced out a little bit. And honestly, most systems that I see are not CPU bound. So after updating stats, recreating those plans is not a big deal. I would want to know why you're updating stats nightly. That's a separate question. But hopefully I answered your original one. Let's see. Could you, in the short term, set up an extended events to capture actual and estimates? You can set up an extended event session to pull the actual plan for a query, but there is significant overhead in doing so, and the reason is because when you use that event in extended events, it pulls the plan for the query every single time, and if you're not filtering properly, you can really introduce a performance issue because of the overhead with pulling that from the plan. So that to me is really a last effort. And if you want to email me and ask about that further, I can talk about that. I think that my colleague Jonathan also wrote a post on that. So let's see. Oh, Robert asked a question about partition. Robert, follow up with me. We'll talk. That's more than I want to get into today. Would that be the same if the primary key? Frank, I missed it. This was a specific demo, so I can't help you that. The question is, what was the name of the add-in to the Sentry Plan Explorer? If you Google SQL Sentry Plan Explorer, you can download Plan Explorer itself, and then you can download an add-in, and the add-in allows you to do this right-click view with SQL Sentry Plan Explorer. So there's 2 things that you can download from SQL Sentry for free. Again, what is the solution to tackle plan cache? Oh, my friend, where do we start? I don't actually really have time to get into that today. What I would recommend in terms of talking about plan cache, Kimberly has some really good posts. So if you Google Kimberly plan cache, you're going to get to some of hers. And when you're talking about plan cache performance issues with different parameters, one of the things you can talk about there is doing a recompile. But recompiling means that every time I run the query, it recompiles. It generates the plan. So depending on how often I run the query, I may be recompiling a lot. Not such a great thing to do. So Kimberly, in addition to having some blog posts, she has some courses out on Pluralsight. She's got 3 courses now which really talk about plan cache, and she's got one that talks about recompiles. So if you really want to understand a little bit more, I would definitely recommend checking out her stuff on Pluralsight. Again, it's subscription based, but it's $30 a month, which is quite honestly, I think, a steal. Eric has a great point for me to mention, which is I'm clicking on this and you get this pop-up. Right? And sometimes that's distracting because I click over here and I'm going to purposely annoy you all by doing this. He reminded me, there is a properties window. So if I select F4, you see over here on the right, I get this properties window. I get a lot of the same information I get in the pop-ups. I get the plan, I get actuals, I get estimates, and I actually even get more. I get my output list. And notice that as I click on my index seek, the output in the properties window changes. Key lookup changes. We could probably spend a half an hour just talking about the properties window. Thanks for that reminder, Eric. I appreciate that. Can I free cache? Can I free procedure cache for a single query? Yes, you can. So what you would do is you would do dbcc free proc cache, and then you put in the plan handle here. You can also do this for a particular database. You can free the procedure cache just for one particular database. I can't remember what you pass in there. I think it's database ID. Another question, does update statistics online require enterprise? No. When you update statistics, that's updating statistics online isn't actually the correct terminology. I think what you're thinking of is doing an index rebuild online. Doing a doing an index rebuild online, yes, that requires Enterprise Edition. But updating statistics is not Enterprise Edition specific, and it's an active online process always, meaning when I go to update statistic, it starts to read through the data, and then as soon as it's done, it's going to display, or it's going to put the updated statistics in the statistics blob. So hopefully I answered that one. And I think I got through most of my questions. I don't know if that means that I explained things so well that there weren't a lot, or if y'all were shy about asking them. But anyway, Steve, I got through most of those. Again, sorry, one last thing before I let Steve take over. I have a hard time stopping talking. If you have questions, feel free to email me, contact me. Questions are great. They help build content and demos for this, so I appreciate that.
Thanks. I mean, I really enjoy listening to you. I can't wait to go back and sit here and just listen to it. So anytime you want to go over time, that's fine with me.
Well, thank you. I enjoy these sessions a lot, and I appreciate the opportunity. And we had no internet issues today. Hooray!
That was really good. I really think of you as one of the best teachers out there. A lot of the people at SQL Skills are very good, but you're one of the best.
Oh, well, thank you. That's a huge compliment. Thank you.
And that's why we enjoy you so much here. So, okay.
Well, I look forward to meeting you at Summit, Steve. And if any of you are going to Summit, anyone who's listening, definitely feel free to look me up and say hi. I'll be there all week.
We're giving away our $25 Amazon gift card. It goes to Yuhong Huo. I'm not sure if I pronounced that right, but we'll be getting that to you. Next month, we'll have Changing Your Habits and to improve your T-SQL performance with Mickey Stewie, so please sign up for that. And thanks. I really appreciate everybody joining in.
Bye, all.
Bye.